Yeah, so if you now go to our outline is actually here. We can actually see that so far so good. We are still following the building blocks of programming, which I hope that right now majority of us understand what are variables. Now you can work with different types of data in Python, such as integers, float, strings, Boolean, list, tuples, and dictionaries. We did them here. And now yesterday we introduced Python conditional statements, and we saw that with Python conditional statements, they allow decision making by executing specific block of code, whether a condition is based on true or false. So now today, we want to proceed with the same by now talking about Python looping statement. And what you're going to see is that looping statement will enable a repeated execution until so it will allow us to have repeated execution of block of code until a certain condition is met. And now later we're going to introduce functions, okay? And then by now interacting with functions, we would have now completed the basic Python, which is actually the first 5 modules: variables, data type, condition, looping, and function. Then later we are going to discuss the 3 more, the OOP, the exceptions, and files operation. So now let's start on Python looping statements. So I want you to go and open the looping statements here. Open the looping statements here. Python looping statement. And then similarly, so that now we are ready, I also want you to open the link. It's actually below. So the link is already here. So this will be our guide notebook. Just click on it. Just click, sorry. And let me first go back. I think I didn't want to do that one. Let's just open first the notes. So open the notes here. Python looping statement. So these are the notes that we want to go through, basically to understand what are Python loops. For our practical examples, we are going to use this notebook link that we have actually added below there. So you can actually open it up already. For those who are not able to access the link, similarly, I'm sharing the link on the chat. And then from there, as usual, I would also advise we open a separate notebook for our class practice as usual. So just create a separate notebook. So it should be Google Colab. So search on your browser, Google Colab. Then as usual, I want you to create a new Google Colab notebook. And the Google Colab notebook, I want you to label it Python looping class practice. So this is actually Python loops class practice, and this is actually for our morning session. Yeah, so definitely we hopefully are going to have for our evening session. So we are going to do the same. So if you're ready, I hope you're ready now. So you have the notebook. You have the notebook for your class practice. You see where you're going now to practice the looping statements. You have the guiding notebook that you want to follow, basically to understand how to work and interact with Python loops. And now from there, we are now starting from now the notes here so that now we can understand what are Python loops, okay? What are Python loops? So if you're ready now, maybe we can start. And we can say that looping statements in Python allow for repeated execution of a block of code. That is the main work of a loop. So they help automate repetitive tasks, making programs more efficient and reducing code redundancy. So that is the main idea. So idea of loops is that you are now allowed to have a repeated execution of code, helping you automate repetitive tasks that you're going to see. And this will actually make our programs more efficient and reducing redundancies that we might have in our codes. So characteristics of a Python loop is that there is some iteration. So this is actually when loops execute blocks of code multiple times until a condition is met. So that is actually what we call iteration. So we're also going to notice that with Python loops, there is some kind of control flow, just like yesterday, in such a way that it is used to control the sequence of program execution. So like we had said yesterday, we have two types of control flow. We have conditional flow, where program execution is controlled by the condition in place. And now we also have the looping control flow, where a piece of code is repeated until a condition is met. So in Python, we support majorly two types of loops. So Python majorly supports two types of loop. So we have a for loop and a while loop, and we're going to see the difference between the for loop and the while loop, and where you can work with the for loop and where you can work with the while loops. Then later, we're also going to see that loops have some special keywords that can alter loop execution. So these special keywords are the break keywords and the continue keyword. And you're going to notice that they can actually change how the loop executes. So in Python, just like we've mentioned here, we have for loops and while loops. And now to have the difference, so for a for loop, it is mainly used to iterate over sequences like lists, tuples, strings, dictionaries, and range. So this is actually where we work with for loop, okay? Because it executes the loop body for each element in a sequence. So that's something we're going to notice. On the other hand, while loop run as long as a specified condition remains true. So it's commonly used when the number of iterations is not known beforehand. Okay, so this is when you know the number of iterations you're going to have. This is when you don't know how many iterations you're going to have in your loops. Okay, so we're going to demonstrate that one. I think this is kind of a repetition. Sorry for that one. So now from there, we have the loop control statements. I've mentioned about the break statement. And the break statement terminates the loop immediately when a condition is met. So you're going to see that one, that when, as much as you're running your loop, if you work with a break statement, then the loop terminates immediately when a specified condition is met. And now with the continue statement, it actually skips the iteration and proceeds to the next one when the condition is also met. So we have the break that terminates a loop, and we have the continue statement that skips an iteration. Also, we have the else statement, which is actually used to execute a block of code after the loop completes, provided that there is no break statement was encountered. So where do we work with loops? Loops are actually used to iterate over data, especially data scientists. So it will enable us to efficiently process data stored in lists, dictionaries, and other collections like sets and tuples. So also, if you want to do automation in Python, so loops are also essential for automating tasks by actually reducing redundancy and providing by automating now repetitive actions in your program, okay? So you can also work with loops, especially when you want to search and filter information. And this is actually help us find and process specific elements within our data set. And also finally, we're also going to see that loops are also used for implementing counters and timers. So these are actually scenarios where we require incremental execution. So we're going to notice this one later. So in summary, we can actually say that loops enhance efficiency and readability programming. So for loops are ideal for iterating over known sequences. So basically, you work with a for loop when you want to interact with sequences like a list, tuples, dictionary, sets. On the other hand, we can work with the while loop when we are working with the iterations that are unknown. Let's say you want to interact over an iteration that you're not sure how many times you're going to iterate. So that is where we work with a while loop. So it's also good to remind us that we need to set proper loop condition so that we prevent infinite loops, because infinite loops is basically a loop that will never terminate, and ensure that we have a controlled execution. So this is something you're going to notice as we are now doing the class practices on Python loops. So where can we apply Python loops in real world examples? So I thought I should share where you can be using loops so that you see the importance of learning the Python loops. So a good example is when we want to process large data sets, especially if you're doing machine learning and data analysis. We can actually iterate over large data set, perform calculation, and extract meaningful insights. So those who are doing big data, we also have something called web scraping, which is actually when you want to extract data from website, so with loops, we can navigate multiple websites and retrieve relevant information. For example, you have job listing, product details, and so on and so forth. So it's something you're going to do in our data science classes, web scraping. We can use it to automate repetitive tasks like sending bulk emails. We can use it for user authentication system by checking a locking account after a certain number of failed attempts. Like if you even check on your, let's say, give a good example, like in your Safaricom line, you're only given 3 attempts. If you have failed attempts for 3 times, then we can actually lock your account. We can use it for building chatbots. We can use it for generating reports and summaries, automations. We can use it for real-time data processing, okay? So that's such as tracking livestock market prices and updating our BI dashboards. Also, you can work with Python loops in cybersecurity to do what we call log monitoring. So this helps in scanning the logs and detecting security threats by analyzing patterns in data. So basically, in short, we can say that loops have so many application area, and it's one of the building block of programming that we cannot do without, okay? So with that one, I'm sure you're going to read more about the applications. So allow me now to go to the class practical projects so that now we definitely have the confidence to work with Python loops. So we want to use the notebook here. So there is a notebook I have uploaded. I hope you have it. It's labeled Python loops and its operation, okay? Then this is where we want to try out some class practices so that now we're able to work with loops. So let's start. In terms of definition for this notebook, we are being told that similar, life is full of routines. So you do some different tasks. Therefore, in programming, we also do lots of repetitive actions. This is in order to handle repetitive tasks in programming, we now use Python loops. And therefore, Python gives us two types of a loop. So we want to start by discussing the while loop, where we say that the iteration is unknown. The for loop, when you want to loop through sequences like list, tuple, dictionary, set, and so on and so forth. So let's start with the while loop. Let's start with the while loop. So I think we can say Python. So if I just want us to do a practice here, we can say Python looping statements. Sorry. Python looping statements. So we can actually say it is used to perform repetitive tasks. What am I doing? So repetitive tasks and reduce redundancies. Yes, that is the main idea. Redundancies, or should have been redundancies. And now we've seen that in Python we have two types of loop. So we have number one, we have the while loop. So in summary, we can say that the number of iterations is unknown. That is what you've seen. It is unknown beforehand. So you're not sure, you're not exactly sure how many times you're going to perform the iteration. So that is where you can work with the while loop. And then later, we're going to talk about a for loop, which is also very, very important. So for loop, and you're going to see that, so it is used, so it is used to loop through sequence data types. A good example, if you want to look through data that you stored in a list, data that you stored in a dictionary, you stored data in a set, you stored data in a range, this range that we're going to talk about today, and so many other sequence data types, even including even a string. So even a string is a sequence, because string is made of sequence of characters. So anytime you want to look through sequence data types, like list, dictionary, set, tuples, range, strings, etc., then that is where you work with a loop. So let us start with the while loop, then we go to a for loop. So let's start here with a while loop. So I hope you're ready. I hope you're ready. In case you're now doing your class practices, I think this is something to note in a comment. So you can actually copy that and paste it in your comments, so that now we have some quick summary about what are looping statements, where do we use a while loop, and where do you work with a for loop. And now we want to start with while loops. So let's go back to our class practices. Let's go back to our class practices here. And now we can say that we use the reserved word while. So while is a keyword. Remember, we said this is a keyword to make a while loop. And therefore, it is used to execute a block of statements repeatedly until a given condition is satisfied or a given condition is met. So when the condition becomes false, the lines of code after the loop will continue to execute. So this is actually how you create a while loop. So what you do, you start with a while keyword, then you pass a condition. So until this condition is met, this block of code that is indented here will always be executed until this condition becomes true, okay? Until this condition becomes true, this code here is executed. So that's why we are saying that until a given condition is satisfied. So until this condition that we have actually placed here is satisfied. So let's give a good example. Let's say you have created a variable called count and you've initialized it to 0, okay? So now you can now say that while I take this count and I put a condition that this count is less than 5, I want to print the count and then increment that count by 1. So let's demonstrate this one and see how it works. So let's copy that one. Just copy. You can actually press Control-C, Control-C. Then you can paste it here. Control-V. And then now we can demonstrate what we are talking about here. Okay. So we have a variable. In case you don't have this one, I can also share on the chart that one. So in case, I don't know whether I've shared everything. Sorry. Look. Now you're good. So what you're saying here is that we have a variable called count. And this variable, we've assigned it 0. So this is where we want to do our loop. So then, while this 0 is less than 5, we are going to print that count, and then we increment that count by 1. So let's print this one and see what happens, so that now we can demonstrate it clearly. So if you run this code, waiting for it to connect to the Google backend engine here. So that now we can get the interpreter. So we have it. So let's see what happens here. Let's just confirm what happens here. Okay. So initially, the count is 0. I want us to start from there. Initially, the count is 0. Now we have to say that while this count, so we have to say is 0 less than 5. The condition is false. So the condition is false. So it is false to say that 0 is less than 5. So because this condition is false, I am going to print that count, which is 0. I hope you can see that first occasion. So now the count was 0, and because 0 was less than 5, we print that 0. Okay? Then after printing that 0, we can now perform what we call an incremental operation, where we say that this count was 0. Remember, this count here was 0. So this 0, we are going to pick that 0 and increment it by 1. So now our count becomes 1. So we have incremented our count from 0 to 1. And now we go and check the condition again. So until that condition becomes true, that is when you're going to stop. So now because my count is 1 still less than 5? Yes. I am going to print that count at 1. So that is the second iteration. And then we do the same. Now we're saying that now my count is 1. I want to take that 1, I increment it by 1. So now my count becomes 2. And now if I check, is 2 still less than 5? Yes, that condition is still false. So we are going to print that count. So we get 2 here. Can you see that one? Then proceeding further, 2 plus 1, 3. So the count is 3. So 3 is still less than 5. We print 3. Okay. We print 3 here. Then from there, we go to when the count is 3. So 3 plus 1, the count becomes 4, and 4 still is less than 5. So we print when the count is at 4. And now we increment that 4 to 5. So we want to say that 4 is equals to 4 plus 1, that is 5. And now at this point, we want to say that is count 5 less than 5. I think that now that condition will terminate to false, because it is false to say that 5 is less than 5. It is true to say that 5 is equal 5. So at this point, because this condition now becomes false, this is when you call now the condition has been met. So the loop has to terminate. So I would wish to explain that one. In case you've not understood, you can ask a question. So you're saying we start from somewhere. We start from the count is 0. 0 is less than 5. that is true, we print 0, then we take that 0, we perform an increment, then we check again, we perform an increment. So we'll do this operation repetitively, so repeating that operation until the point where this condition becomes false. And when this condition evaluates false, the loop is actually terminated, okay? So that is actually how a while loop works. So a while loop will have 3 components. We'll actually have, so it has 3 components. So if you want to understand how a while loop works, then it has 3 components. The first component, A, is the start. So the start is whereby a value is stored in a variable. So a value is stored in a variable. So that is the start. For example, here, count is our start. So you want to start counting from 0. So this 0 is stored in variable count. B, still in a while loop, we have a condition. So this is a condition that is checked. So this is the condition that is checked to decide. So to decide if we are still proceeding with our loop, still proceeding with the loop. And then finally, the last thing we have in a while loop is now the increment or decrement. So you also have the increment. Sometimes you can also have a decrement. So this is actually when we want to increase we want to proceed, let me just say, we want to proceed to the next iteration. We want to proceed to the next iteration. When you want to proceed to the next iteration. So by using these 3 now, we can also explain this one again. We can say that count is our start. So you want to start counting from 0. So that is the start. We store the counter in a variable at 0. Then from there, Hello, sorry for that word. Can you hear me now? So I was actually explaining the while loops. I was actually explaining the while loop, and we were saying that a while loop is when we have three components. So we have the start, and normally the start is where we store a value in a variable. For example, when you want to start from 0, we store the count at 0. Then we check a condition, and this condition is actually determining whether we want to still proceed with the loop. So we can proceed with the loop when we say the condition is true. When the condition is true, we proceed with the loop. So in this scenario, 0 is less than 5. Because that condition is true, we are going to print that count. And then we have the third component, which is actually the increment, which will actually increment our start to the next iteration, which is now 1. And then we check the condition. So until this condition evaluates to false, that is when we are going to terminate our loop. So I can see there's a question from Kelfas. You're asking, what if you work with infinity instead of 5? So if you that is when you want to create an infinite loop. Basically in Python, to create an infinite loop is just pass a condition that will always evaluate true. So a condition that we always evaluate to true will actually give us an infinite loop. I think you're going to demonstrate that one in a short while. So moving next here, so the syntax is, so sorry, we're actually saying that in the above while loop, the condition becomes false when the count is at 5. That is what we saw. So this is where now the loop stops. And if we are interested to run the block of code once the loop is no longer true, we can actually work with else. So if you want to run another block of code when the condition has evaluated to false, we can actually add an else condition here. So we are now saying that while this condition is always true, I will always execute this code that is here. When it's false, I'm supposed to terminate. But if I want to execute another block of code when this condition becomes false, I can now add an else part here. So for example, here, I think let's just copy this one and see what happens here. So let's add it here. So we can paste it here. So we can actually say, here we're actually saying while loops with else statements. While loops with else statements. So we are now saying that with else statement, we are going to execute another block of code after the condition has evaluated false. So if I run this one, we can actually see that the count was 0, and we executed when the count was 0, when the count was 1, when the count was 2, when the count was 3, when the count was 4. Now when the count became 5, so when you say that 4 is equal to 4 plus 1, the count became 5. And then this loop terminated when the count is 5. So when we add else, we can actually print that count, which is 5. And that is actually a scenario where you want to execute the code of a code when the condition has evaluated false. So it's a scenario now whereby we're now printing 5. So to explain this one, we're being told here that in the above condition, we will be, in the above loop condition will be false when the count is as 5 and the loop stops. And the execution starts at the else statement. Then as a result, 5 will be printed. Okay, so 5 will be printed because the loop terminated when the count was at 5, the condition was false, and now we print that 5 here. I hope it makes sense. So before I go to break and continue keyword, we can also talk about the infinite loops, just like Kelfas wanted to showcase that one. So So just to answer Kelfas, we also have the infinite loops. So these are basically the loops that will never terminate. So I want you to imagine you have a loop that will never terminate in your program. So for you to have that one, the condition has to be always true. That condition has to be always true. In this scenario, you're saying that if I have my count starting at 0, okay? Okay, just to give it a shorthand, we can actually say that while I have a condition that will always evaluate to true, we can actually now do the operation that will never stop. Like, for example, I can do an operation like server is running. You remember, servers must always run. So in this scenario, this server must always be running because this condition will always evaluate to true. Okay, this condition will always evaluate to true. So the server will always run. So if you run this one here, you're going to see that this is a condition that will never terminate at any given point. Okay, it will never terminate at any given point. So if you want this condition to stop, then you can actually click on the stop button here. So the user can interrupt it. In case the user does not interrupt it, it will never terminate. So that is what we call an infinite loop. I want to terminate it here like that one. So it is an infinite loop that we have a condition that will always be true. So if you don't want to write true, then you can actually say something like, let's say 1 is always equals to 1. That is also true. 1 is always equals to 1. So this also evaluates to true. Okay. So just to give it a shorthand property, you just say that while I have a condition that will always evaluate to true, I will actually run an infinite loop. So I want to share this one with you. And now maybe you can try it out on your end and see whether you can build an infinite loop. Can build an infinite loop. Okay. So I hope that is okay. If I want to close this one, you can actually hide that one there. So it's what we call an infinite loop. The condition will always evaluate to true. So now proceeding, we add some control statement that we call the break keyword and continue keyword. So this is part 1 for while loop. So break keyword, we use break keyword when we like to go out of the loop and stop. Okay? So we can actually have the syntax like this one. While I have a condition that is always true, I am going to execute a block of code here. Now, if I have another condition here that is met, then I'm going to terminate that loop. So a good example is here. My count started from 0. So while this condition is always true, we are going to print the counter, and then we are going to increment it here. Now we're saying that when this count reaches count 3, let's break that loop. So what this would happen is that the loop will terminate when the count is at 3. So let's just run this one to demonstrate that one here. So we can actually say break keywords. They are used to terminate a loop with a condition. So a good example is this one. So let's see what happens. Sorry for that one. So I was saying that if you look at that piece of code here, our count started from 0. And now we are saying that when 0 is less than 5, that is true. I am going to print that count, and then I'm going to increment that count by 1. So then I go to 1, and then I'm going to check whether is 1 equals to 3. So I'm not going to break at that point. So now from 1, now I can now say that count 1 is equals to 1 plus 1. Now we have 2. So 2 is less than 5. So before I print this one, I can check whether 2 is equals to 3. Okay. If that is the case, I should have break, but I will not break. So I'm actually going to print 2. Then I'm going to increment 2 is equals to 2 plus 1. So before I actually check the condition here, I check whether if this count is equals to 3, then I should break. So at this point, we are actually terminating our loop when the count is at 3. So the condition is that when we have count at 3, we terminate the loop. So that is actually why we are getting this output here. So to explain this, when you're being told that the above loop only prints 0, 1, and 2, but when it reaches count at 3, it stops. Okay. So because now with this break keyword, a loop will be terminated when this condition is met. So I hope that one is okay. You can try it out. Let me share this one. You can also try out this one. And then we go to continue statement. That one. So with the continue statement, this is actually where we can now skip an iteration and continue to the next. So we can skip an iteration and then proceed to the next iteration. So this is a good example. So while I have a condition, I will always print this code. If I have a condition here and then I call the continue keyword, we are actually going to terminate that. We are going to skip that iteration. So to demonstrate that one, we can actually work with this piece of code here. Then we can actually add it here. So we can paste it here. And then we can say the continue keyword. So this is a continue keyword. Continue keyword where an iteration is skipped when a condition is met. Okay. So in this example, our count started at 5. We want to check whether at 0. Sorry, we want to check whether if this count it's okay, then we check whether we have reached 3. If that is the case, we are going to continue. Okay. So if you run this code, we are going to see that we started at 0 because 0 is not less than 3. We went to 1. 1 is still not less than 3. Now when we reach 2, 2 is still not less than 3. Now when we reach when the condition is at 3, when the count is at 3, that iteration we continue it. So we are going to skip that iteration and going to the next one. So we normally use continue keyword when we want to skip a certain iteration when the condition is met. So let me share this one with you. Unless you have a question, maybe we can now proceed to the next part. Okay. Sorry for that one. Like that one. So the difference is that break keyword will terminate a loop when the condition is met. On the other hand, continue keyword will skip an iteration when the condition is also met. So any question up to there? Before now we start on for loops. before we now start on for loops. Yes, I pardon on continue. So we are saying that continue is when we want to skip an iteration. So in this code, we're actually going to print 0, 1, 2, and 4, then we are going to skip 3, because when we have a condition that if the count is at 3, we will actually continue that one. So to continue is to just skip a certain iteration. So in a good example to demonstrate where you can work with the count is when we say, when you want to list all students, and skip students who their fee balance is less than, let's say 3,000. So you want to list all the students, and you only want to skip students who their fee balance is less than 3,000. So that is actually where you can now work with a continue. So with continue, we just want to check, is your fee balance less than 3,000? Yes, we continue. So we skip your information. So basically, that is actually one occasion where we can work with a continue statement when you want to skip a certain iteration when the condition is met. Okay, when the condition is met. I hope now that one makes sense. Okay, so if that is the case, then now we can start on for loops. We can start on for loops. We can start on for loops. And now we can say that. So let's start with for loops. So we had started with while loop, number 1. So we had started with while loops. So number 1, this is while loop. Number 2, now let's talk about for loop here. Let's talk about for loops here. Let's talk about number 2. Let's talk about for loops. And now we're being told that with for loops, a for keyword is used. Instead of a one keyword, we work with the for keyword to make our loop. And this is actually very similar with other programming language, but now its syntax is a bit different. And we're going to see that a loop is used for iterating through sequences. That is, we work with the for loop whenever you want to iterate through sequences, like when we want to iterate through a list, when you want to iterate through a tuple, a dictionary, a set, a string, or even a range. So this is actually the syntax. This is actually the syntax. We have the keyword for, and then we create an iterator. This iterator will actually go through a list. So we're actually starting with a list. We are starting with a list. We are saying that they are used to iterate through sequence data types. Like you had said, they are used to iterate through sequence data types. For example, when you want to iterate through a list, a tuple, a dictionary, sets, strings, and even the range that we never did that, but we'll do it here today. So to start us off, we can actually say, let's start with A. We want to iterate through lists. So the syntax we're being told is that we just have to create for keyword and then have an iterator that will go through the list. And then now we can perform our operation. For example, in this code, we have a list of numbers starting from 0, 1, 2, 3, 4, 5. And now we want to say that for this iterator is basically a variable that will actually go through the numbers and then we print out the number. So we're being told here that the number, this one here, it's a temporary name to refer to the list of items in numbers. And it is only valid inside this loop. So it's actually a local variable. So it's actually a temporary name that will refer to the list of items that are inside that list. So whenever we print number, so this number will be printed line by line, starting from 0 all the way to 5. So we can actually print 0. The first location, the number will be 0. So we print 0, we go to 1, all the way up to 5. So let's try this one here. Try this one here. Try this one here. Like that one. So if you run this one, I hope you can see that this number, it's actually something like an index number, and it starts from 0. So you're going to say that I want to go to this list of numbers and access a value at index 0. So you're going to find we have this value here. At index 1, we have this value here, index 2, index 3, all the way up to index 5. So when we have actually gone through all the items in that list, then our list will terminate. So I could even have another good example. I also have another good example here. So I can say print. And then I have this a delimiter. And then we say now, let's say these are the students. These are the students. So the students we have is a list of students starting from, we have a student called Jeremy, another student called Anne, another student called Mary, another student called Bob, and then finally another student called Kennedy, etc. So in this list of students, we have 5 students. So we have Jeremy, we have Anne. So Jeremy, it's at index 0, Anne, index 1, Mary, index 2, Bob, index 3, and then Kennedy, we have at index 3. So to iterate all through all these students, we can actually say that for an iterator that is called for every student in the list of students, I want to actually print a student. So if you run this one here, you're going to notice that now we have Jeremy. This Jeremy was when this student was at index 0, so we printed Jeremy. We incremented this student to index 1, we printed Anne. Index 2, we printed Mary. Index 3, we printed Bob. Index 4, we printed Kennedy. When we incremented to index 5, we didn't find any student here, so the loop had to terminate here. So I want to try out this one, and now we can see the comparison where you are actually using a for loop to iterate through a list. So I'm sharing that one. Sharing that one there. Then from there, we can also now proceed to the next part, where you can also iterate through a string. So you can also iterate through a string. So B, we can actually iterate through strings when you want to extract some characters from the string, some characters from the string. So a good example of being demonstrated to us here is this scenario where we have a string called Python. So the language is a string called Python. So we have to say that for every letter in the string Python, we can actually extract all the values. So let me just copy this one here. And then we can paste it in our program here. And we want to say that I have a variable language which has stored a string called Python. So I want to extract every character in this variable, and then I print it. So if you run this one, because string is also a sequence data type of characters, we're able to get at index 0, we have P, at index 1, we have Y, And now the list continues in that order. So I want to try this one. For the range, I want to skip it for now. We are going to talk about it later. So I hope you're also trying that one. So I want to skip this one for now. We'll talk about range. So we can also do the same for tuple. So it's the same for iterator in a tuple. We just go and extract all information in a tuple. I just want to demonstrate that one as well. Yeah, so see we have a for loop that iterates through a tuple. Sorry. This is it. We have a tuple. So for example, we have numbers that is stored in a tuple. And because these tuples are still immutable, we can still access the information through a loop. So if you now run this one, you're also getting information from a tuple. So I'm sharing this one on the class link. In case you have a question, now you can ask. Still no question, so we can still proceed. So this is a tuple. So we have numbers that is stored in a tuple. So for every number that is stored in these tuple numbers, I want to extract this number. So this is a temporary variable that will refer to the list of items in this tuple, just like we had for the list. Okay. So moving further, we also have for loops when you want to iterate through a dictionary. It's the same. So for loop with dictionary, we can actually give you the key of that dictionary. So for example, here we can say this is a syntax. For iterator, a temporary name that will always refer to items in dictionaries, we can actually extract them here. So for example, in this scenario, I want to copy this tree here. I want to copy this tree. And now we are saying here, dictionaries. Then I paste that code here. And now you're saying I have a dictionary. I have a dictionary called person. We have the key first name, value, last name, there's a value, age, there's a value, and so on and so forth. Therefore, if I want to get only the key, I can actually say that for every key in the person dictionary, I would only print their keys. So let me first have some kind of delimiter here so that we separate the two. That one. So if I run this two, in the first occasion, we are getting only the dictionary, the key. So the key, this person was first name, last name, age, country, is married, skills, and address. So you're actually saying for every key in this dictionary person, I want to print the keys that we have here. Alternatively, we can also print the key and the value, okay? The key and the values. So in such a way, I think this should have been, we should have been even specific. We say, if you want to say the key, you can say person.keys. Go to say that one. So this is person.keys. We are going to get all the keys. Then here, you can also say, if I want to get only the values, so these are the key. Let me say, these are the keys. These are when you want to get the values. This is when you want to get the values. And then finally, this expression when you want to get both key and values. So if you're seeing that if you want to get the key, you can just say for person.key, I want to get only the key. If you want to get values, you can say person.values to get the values. Then if you want to get both key and value, you can actually say person dot items. So both items are the key with their values. So if I run these three, now we're going to see that the first scenario, we get the keys because we said we want person.keys. In the next scenario, we are getting all the values. So because we had said person.value, dictionary.value, and the last occasion, we're actually getting both key and value because we used person.item. And now we're getting both the key and the values, key, values, and so on and so forth. So I want you to try out this one. And now let me know whether it's also working on your end. So any question up to there? Question up to there now? Any question up to there? Okay, so let's proceed. We have actually extracted the keys. We are getting the keys from a dictionary. If you want to get values, we actually say values. You get all the values. And if you want to get both keys and values, we work with items. So that is when you want to get both the key with its associated value from a dictionary. So any question up to there? So far, so good. So if there is no question up to there, we'll proceed to another sequence, which is set. So we said that sets are unordered, and we were not able to extract their values. So if you want to extract values from a set, we can actually work with a loop, specifically a for loop, where we're saying that for this iterator, which is a temporary value, that will extract values from the set, we can actually now extract them here. So this is a good example. Sets here. So this is sets. We can add a code cell here. We say sets. That one. So we have IT companies, Facebook, Google, Microsoft, Apple, IBM, Oracle, and Amazon. So we actually want to say that for every company so if the company exists in this set IT companies, we are actually going to print them out. So if you actually see this one, we're able to get them in a random. So they are actually in a random because we said that sets are unordered, so we can actually print them out in any order. And if you run this one again, and now you're seeing that we are actually printing Apple, then we go to Microsoft, then we pick Amazon in any order in that set. So that is also something we mentioned. We say that sets are sequence data types where items are unordered, but we can work with a for loop anytime we want to extract values from a set. So if none, still no question up to that point. So the idea is to understand that this is the iterator and this is the membership operator to check whether we have this iterator in this sequence here. Okay, so this is the iterator that we check whether we have it in this sequence here. So moving further, we can now talk about break and continue. So in short reminder, we say that break, we use break when we like to stop our loop before it is completed. So before we complete extracting all this value, we can actually break at a certain point. Or alternatively, we can still continue where we skip an iteration at a certain point. So a good example is for an iterator that is actually going through a sequence, which can be a list, tuple, dictionary. We'll actually print that code here. If a condition is met, we break. So for example, this is a tuple. This is a tuple. This was a tuple. So now we are talking about break keywords. Break keyword. So a good example is here. We are saying that I have numbers that are ranging in a tuple starting from 0 up to 5. So for every number in the list of number, I want to print that number. But if that number reaches at iteration 3 here, I want to stop. So if you run this one, you're going to notice that we are printing 0, 1, 2, 3. So we are printing up to 3, then we break. We stop iteration at that point. So this is actually a scenario where you don't want to print all the items in that sequence. Okay. So I hope you try that one here. We've already demonstrated the break keywords. Break keywords like that one. Then from there, we can also try out. So we are being told that in the above example, the loops stopped when we reach 3. So in this continue, we will use to continue when we like to skip some steps in our iteration. So this is actually the syntax for iterator that goes in a sequence. If the condition is there, we just continue. So this is actually the good example to demonstrate. So let's try this one. Let's try this one and see what happens here. So this is actually the continue keyword that you're saying. We use it whenever we want to skip a certain iteration. So if I run this one, let's see what I get. So this is basically here to showcase that we are outside the loop. So we're actually here. Now we're saying number starts from 0 all the way to 5. So if I take 0 in the list of number, I'll print it if that number is not equals to 3. So I'll continue. So I'll print 0. The next number should be 1. So I print 1. The next number should be 2. I print 2. The next number should be 3. And it was actually printed 3. Okay, let me just remove this one. Just remove this 2 here. Just remove this one. I think they're a bit confusing there. So it is not actually skipping that one. So this means that this print, if you can see this one, should be here. It should be here. Yeah, it should be here. Let me just see whether that should work now. If that was confusing. Yeah, I think that one now it works. So we are now saying that with continue keywords, we skip a certain iteration. So we want to say that for every number in this list of number, if that number is 3, we are going to skip that number. So we start from 0, we go to 1, we go to 2. If the number is 3 here, we are going to skip that number. So we are going to continue to skip an iteration when a condition is met. So the condition is met when the number it's at 3 here. So then we proceed with 4 and 5. So you can also say we are going to skip when the number is 3 or when the number is something like 4. So you can actually skip 2 at a time. We are now skipping when the number is 0. When the number is 3, we skip. And when the number is 4. So this could be an example whereby we want to skip your name when your fee balance is less than 5,000 or when you are in Form 4. So you want to chase away students. So you want, let's say you are in a scenario whereby you want to send students back home for fee collection. So remember, you don't want to send all the students home. Okay? So you actually have some exemptions. You have some exemptions. The exemptions is number 1, let's say your fee balance is less than 5,000. And maybe the other exemption could be, maybe you don't want to change from 4 students when you are in Form 4. So any other student who they don't meet this condition, their information will be printed here. So in this scenario, you can work with, I want students who their fee balance is less than 5,000 or students who are in Form 4. So I will continue. So to continue means I will skip their records and only print all the other students. That is actually one good scenario where you can work with a continue statement, basically to skip iterations, in loops. So I want to share this one with you. In case you have a question, basically you can just ask at this point. So moving further, in the above example, we saw that if the number is equals to 3, the step of that iteration is skipped and the execution of the loop continues there, and the other iterations are left. So finally, we can also work with loops in a range function. So the range function, it is actually used to list numbers, okay? So the range function is basically, you can actually list the numbers from where you want to start, where you want to start, you want to end, or you want to step. So it takes 3 parameters: starting, ending, and increment. So by default, it starts from 0 and then increments by 1. Okay? So this is actually the range function. So let's talk about it here. The range function. So I'm also talking about looping through the range function. The range function pattern. So we can actually say that what is the purpose of the range function? We are saying that it is used to list numbers, basically numbers, based on parameters provided, based on the parameters that you provide. So a good example here is that I want to list 10 numbers. Let me show you that one. So to do this one, I can basically call the list function, and then inside that one, I have a range of numbers up to 10. So if I print this one, let me print this one here. that one, we are going to notice that we are getting a list with 10 numbers, starting from 0 all the way to 9. So I have to see that when you say range 10, it is actually from 0 all the way up to 9. So these are 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it reaches up to 9 because in computing, we're actually realizing that counting starts from 0 in that order. So these are actually 10 numbers. So I want you to try. I'll try that one. That is where we work with the range function. Whenever you want to produce list of values. So a good example, maybe I also want to produce, just have an delimiter here, range, separator here. How about if I want to have a list of 20 numbers? So I can say a list of 20 numbers. So it's very, very similar. You're going to say, I want to list a range of, so for you to get 20 numbers, you have to say up to 20. So it'll go up to 19. You'll go up to 19. So if you print this one here, you print list 20 numbers, then you're also noticing that you're actually producing some list of numbers. Basically, with the range function, we are actually going to produce some list of numbers. So if you say range of 10, it reaches up to 9. Range of 20, it reaches up to 19. So I can add here that by default, the range function starts from 0. I hope you can see, let me just say 0. And increments by 1. I hope you have seen that one. So by default, if you call the range function, it will basically start from 0 and then have an increment by 1. So what about when you have to modify the range function? When you want to modify the range function. So in this order, you're saying that we can also have the range function, then we pass where we want to start, where we want to reach the limit, and here we can actually add the steps that we want to take. So in this example, let's list even numbers between 4 and 20. Let's list even numbers between 4 and 20. So you can say list even numbers, that one. And now we are seeing that for us to reach at least even numbers between 4 and 20, we have a range function that starts from 4. So this is the start from 4. Then 20 is where we want to reach up to 20. And then this is the step. So from 4, you take 2 steps, we go to 6. From 6, you take 2 steps, you go to 8 in that order. So if you run this one, you're also noticing that at some point, we can actually modify the range function to actually have our own start and our own steps. Whereby from 4, we go to 6, step of 2. From 6, we go to 8, step of 2, in that order, up to there. So I hope now this one makes sense to you. I also want to provide this one here. Let me just share this one here. Share this one here. So we've actually modified the range function, that one. So in the range function, you're basically producing a list of numbers. a list of numbers. Now, proceeding with our nodes, we are being told that we can actually iterate through a range function. So for example, we can say for iterator, we want to iterate through this range of start, end, and stop. So this is actually a good example. So we are now saying iterating iterating through range function. A good example is something like this one here. So you want to say, I have a range of numbers that start from 0 up to 11. So for every number in this range from 0 to 11, I can actually print them out. So if you run this one, you're actually seeing that we are now getting all these numbers from 0 up to 10, because we said range of 11. So range of 11, which I should have printed here, list range 11. So if you list the range of 11 numbers, then you're actually going to have numbers starting from 0 up to 10. So then I need that one, yeah, exactly, yeah, that one. So if I run this one, so range of 11, I hope you can see here, range of 11, these are basically numbers that start from 0 all the way up to 10. Therefore, if you have to say for every number in the range of 11, then you're actually listing all these numbers here. I hope you can see that one there. So every number in this list of numbers from 0 up to 10, then that is what we're getting right here. So I want you to try out this one, in your notebooks. Your notebooks like that one. So I hope that is okay. In case you have a question, do you have any question? In case you have a question, please don't forget to ask. So moving further, at some point we have a nested loop that I want to skip for today because of some reasons, and also I want to skip the nested loop for today, but if you have time, you can check them out. And also I wanted to skip the else statement, but if you have time, you can check them out. And also you can also check on the pass statement, whereby you can say in Python, when statement is required after semicolon, after you've actually passed semicolon, you need to pass some statement. But you don't like to execute any code there, we can actually write the pass keyword to avoid such error. So this actually, in case you want to avoid statements, you can actually use the pass keyword. So actually that one will mark the end of our looping statement. I would hope you can now try out these exercises that I've shared here. And then in case you have one that is more challenging, you can always address it in the WhatsApp group, or you can also inbox me through my contact. So up to there, any question? Up to there, any question? Any questions? I want to share this one with you. In case now you want to have the class practices, I want to share this one right here, so that maybe if I was very fast, then you can try them out at your own free time. So any question with loops? So before you actually ask the question, I can actually do the summary. What we've done today, we've said that Python looping statement allow us to perform repetitive tasks, and they'll actually help us reduce redundancies. And we have two types of loops in Python. We have the while loops and we have the for loops. So while loop is when you just have a condition, and then we use for loop when you want to loop through some sequences. So with while loop, we've actually seen that we have three components. You need to have the start, then you need to pass the condition, and then you need to pass the step or the increment, like in this scenario here. You also seen that you can actually work with while loop with else statement. And then we've talked about infinite loops, which are loops that will never terminate. So long as you have a while through a condition that will always evaluate true, then you're definitely going to have an infinite loop here. So we've seen that break keywords are used to terminate loops in a condition. Similarly, continue are used to skip an iteration when the condition is met. And now finally, we've actually worked with a for loop, and we've seen that basically they are used to iterate through sequence data types. And we've seen you can actually iterate through lists. You can iterate through strings. You can iterate through tuples. We can iterate through dictionaries by getting their keys, their values, both key and values by referring to the items. And now we've also seen you can also iterate through sets. We've seen that still they can work with break keyword and continue keyword. And then finally here, we've also noticed that we have a function that is called a range function, which is basically used to list numbers based on the parameters you provide. And by default, you'll actually realize that range function starts from 0 and increments by 1. That is what we've noticed here. Start from 0, increments by 1. But you can also modify in such a way that you can actually provide your own start, your own limit, and then the steps that you want to take here. And now if you want to iterate through the range, then you can just say for the iterator that goes through the range, we can actually extract the value there. So you can actually read more about nested loops. You can also check loops, for loops that have else part. And finally, you can also check the pass keywords. And then later, then you can also try out these exercises. So any question up to there? Any question up to there? Python loops? Any question up to there? Okay, so if you don't have any question, then we will be uploading some quizzes today. We are going to upload some quizzes today. For every module, we are going to have some quizzes that you're going to try out. So check out the e-learning portal later. We'll be adding some quizzes that you can try out. Yeah, okay, so with that one, then I wish to stop at that point. Tomorrow we proceed now with Python functions and modules. Have a good day and bye-bye. Next question. No question. So have a nice day and bye-bye. Yes, I have GitHub, but we will be using GitHub for someone was asking a good question about GitHub. Let me get the name. It's also who's that person? Yes, Dennis, you're asking whether we will use GitHub. Definitely yes, but we are going to use GitHub later in our data science or data analytics projects. Yeah, definitely we are going to use GitHub later in our program. So bye-bye.